Lesson 8.2 is all about graphing a quadratic with a c value added on the end. So the way I'm going to expect us to handle this is pretty similar to 8.1. We'll learn some strategies for doing this a little quicker, but for now we're going to keep with plugging and chugging with a table. So if I'm going to graph something like g of x equals x squared minus 2, compare that to our parent function, f of x just equals x squared. First thing I want us to think about is if I follow order of operations, x squared is going to happen first in both, but then g subtracts 2 afterwards. So g of x is always going to be 2 less than f of x if I follow order of operations. So let's start with a table of values, then we'll actually plot the points. Let's do x squared and x squared minus 2. Should have given myself another. We'll fix that. Give ourselves a third row here, just to compare them all. All right, so we'll do negative 2 to positive 2 like we've always been doing. You should start having your parent function memorized. 4, 1, 0, 1, 4. 2 times 2, 1 times 1, 0 times 0, negative 1 times itself, negative 2 times itself. This is never going to change. It's called the parent function because it's always the same and everything else is just a transformation on the parent function. So this is just x squared, then minus 2. So if x squared was 4, 4 minus 2 is 2. Negative 1 squared was 1. 1 minus 2 is negative 1. 0 squared was 0. 0 minus 2 is negative 2. So it's the same pattern, just these numbers are always 2 less. This is the parent function. So this is called a transformation. Okay, it's something that's happening as a result to changing the parent function in some way. This one in particular, we'll give a name after we look at the graph. It's called a translation or a shift. It's not going to change the shape. It's just going to move stuff around. So let me draw a coordinate grid and then we'll plot the points. All right, let's start with the parent function. We should already know what this is going to look like. 0, 0, 1, 1, 2, 4. Negative 1, 1, negative 2, 4. Nice U-shaped parabola. So this is our parent function, x squared. Now let's look at our g of x that had the minus 2. So 0, negative 2, 1, negative 1, negative 1, negative 1, 2, 2, negative 2, 2. It's basically the same points, just shifted down. See, it's not skinnier or taller or wider or anything like that. It's just shifted. So the common English way I'd describe this is shift down 2. The math term is translate down 2. So it's called a translation when it's just a shift. That's the technical math term for it. So a shift is called a translation. Let's do a couple more. So now we're going to work with g of x is 4x squared plus 1. Now there's an a and a c value. So again, let's start the conversation with what happens if we follow order of operations. G of x is like the parent function, but it's 4 times as tall or as big than plus 1. So in order, we would square first, and then where g of x changes is next, it's times 4, and then plus 1. So if I keep using my table of values, I can just make those changes. So if we keep our parent function in mind, It makes figuring out any other function just a little bit easier. Make ourselves our table again. Same 5 numbers. Again, in the future, we'll find a way to do this a little faster than just figuring out the numbers, but for now, it's honestly not too slow. Get used to the process and it won't be too much for you. So, 4 times as big, then plus 1. What's 4 times 4? That's 16, plus 1 is 17. 1 times 4 is 4, then plus 1 is 5. 0 times 4 is 0, then plus 1 is 1. And then it's going to be symmetric over here. 1 times 4 is 4, plus 1 is 5. 4 times 4 is 16, plus 1 is 17. So g of x got quite a bit bigger. It ended up being times 4 plus 1. And this is just normal parent function. All right, let me get some coordinate grids drawn out, and then we'll plot the points. So clearly this graph of g of x gets real tall. All right, but let's start with our parent function again. I don't even think I'm going to get all the points for the g of x on here. Tried to space it out a little more so that the difference was more obvious this time. But that times 4, remember, that's called a stretch. Times 4 is a pretty big stretch when you're just graphing by hand like this, so it's going to make a big difference. So here's my parent function, y equals x squared. Now let's get g of x on here. 0, 1, and then 1, 5, 1, 2, 3, 4, 5. Look how much taller that already is. And then 17, I've got 6, 7, 8, 9, 10, 11. 17 would be way up here, like off the graph. So I'm just going to put the points up here so I have something to go through. But I don't even think it'd be on camera. But it's way taller and way skinnier. Remember, I plotted the same number of points. It's just this steep, which is kind of crazy. So this is my g of x. This is my 4x squared plus 1. So that was a pretty big vertical stretch. So this one was both stretched by a factor of 4 and then the translation is what moved it up 1. So stretch by a factor of 4 and then translate up 1. So that's my comparison to the parent function. All right, one last problem. So our goal is to graph these, but I'm just gonna fill out a table of values. We'll talk about what it's gonna do. All right, so I'm gonna need 4 rows this time. I'm gonna all my x values, and then I'm gonna start with my parent function. Give myself 1 more row in there. And this is just to organize our work. So x, I'm gonna do our same 5 numbers. -2, -1, 0, 1, 2. And then we'll do our parent function, x squared. All right, that's going to be 4, 1, 0, 1, 4. Now f of x, what does f of x do? Well, first we do what it's multiplied by, so times -0.5, then plus 2. All right, so half of 4 is 2, but negative. So I've got -2 plus 2 is 0. Half of 1 is, well, 0.5. Then I make it negative. So -0.5 plus 2 is 1.5. Half of 0 is just 0. 0 plus 2 is 2. And then we should be symmetric now. Half of 1 is 0.5, but negative, so -0.5 plus 2 is 1.5. Then half of 4 is 2, but -2. -2 plus 2 is 0. g of x is just minus 7 from the previous one. So g of x uses f of x. It doesn't rely on just the parent function. It relies on what f of x was. So this is an interesting new way to use function notation we haven't done yet. This is kind of just, I would substitute f of x in here, but if I organize it in a table this way, I can kind of just do it step by step. All right, so this whole row for g of x is just going to be f of x, but minus 7. I don't have to do all the f of x calculations. I already did that. So 0 minus 7, negative 7. 1.5 minus 7, negative 5.5. Negative 5. Negative 5.5. And negative 7. All right, so the real thing that this problem is trying to get us to do is track, okay, I'm going to plug x into my parent function. How does the parent function change to get f of x? And then can I read this equation and just figure out what happens to f of x to get g of x? So these were my notes to myself over here. This is what was happening. All right, so I start with my parent function. And then since g of x relies on f of x, I want to do f of x first. So this is just kind of the thinking process. This is like getting closer and closer to the kind of stuff you're going to be expected to do in Algebra 2 in a couple of years.